All right, so let's take a look at the Support Vector Machines project, which is good, clean fun. And there we are, Support Vector Machines here. So we're going to need Google Colab as always, and a new notebook. All right, and so first we're going to make a data set. So this installs SecML, and it then makes a simple data set that just uses Gaussian randomness to make some random blobs. And I've just adjusted the parameters so those random blobs will overlap. And since you control the seeding number for the random number generator to set it to 999, you're going to get exactly the same points I got, instead of each of you getting different random points, and that means I'll be able to easily have a flag value. So when I run it, it's there we go, collecting SecML, getting the right Python library, and after it's got the library, it's going to run the function, and then it's going to plot the graph so we can see the data. And there it is. So I have a Gaussian blob of data here and a Gaussian blob of data there, and in this case, they don't overlap. There's clearly room to draw a line between them, and that's what we want to do. Okay. So here we create and train the model. We just get a C classifier scalar vector machine here, and we fit it right there. That's it. And then we just, all the rest of this is just predicting some values and plotting the answer so we can see the answer. So the whole job is done by just 2 lines of code there. All the rest of this is just making it so we can see it. So here's the accuracy is 100% as it should be. We're doing hard margin classification, so it won't tolerate any accuracy other than 100%. And as you can see, it's drawn a line that puts all the reds on one side and all the blues on the other side. And here's the weights. And the weights are similar. You can see this line is pretty much at 45 degrees, so it's weighting the X and the Y similarly, and that's what this is showing. All right, so now we're going to expand the Y scale to show the effect of changing the scale. So this is just going to, by the way, this is the kind of Python I always write. I write Python like it was Fortran because I'm very primitive at these for loops, which cool Python people learn how to not do that, but I haven't. So I just go through all the instances and multiply by 100 and create this training set expanded, and then go back and fit that. But this, I think, just plots it, doesn't fit it yet. So this just shows the whole data with the y-axis expanded, so it looks just the same, just the labels are different, but now this is 100 times bigger. And now we do exactly the same thing as before, except we fit the TREXP, which is the expanded training set, not the original training set. And when you do it and plot the answer, now the line is much closer to horizontal than the previous line. It was pretty much at 45 degrees because it's very worried about having any kind of vertical errors far more than horizontal errors, and that shows the failure of it to handle this. So to get some flags, you have to run it at a different Y. Get a flag, you run it at a different Y scale, and then we can consider soft vector machines. Because, of course, like I see, these hard vector machines are kind of nuts anyway. So I think I'm just going to make a new collab here. Let's throw this one away and start with a new clean one. And all right. So now I just changed the parameters of these things to make data that overlaps. So it downloads some libraries. All right, while that's happening, I'll just get the next one ready to go. Just as before, this is going to create and train the model. All right, so there's the data. Now, the two classes overlap pretty badly. So I guess you draw a line here or something. I'm not quite sure where it's going to draw a line. Let's see what it makes of this. Let me see if it matches my sample here. Yeah, I guess so. Yeah, here. Yep. Actually, it looks like it does not match my previous attempt. It looks really, really messed up. I may have to work on this. It looks like perhaps my picture here does not match the picture you actually get by running those commands. That disturbs me. Let's see if I can figure out the problem. Random state. It seems to me like I ought to be setting X and Y center somewhere. Yeah, here, centers seems to be missing. Here, they're not supposed to be that overlapping. I think the centers are missing. All right, I think I'm going to stop this demo. I'm going to fix this project. I think this is not going to work. I got to go find out what I did. I must have fouled up in the actual, because there must be more to fit than that. And just, if we try to fit a linear model through this, I don't think it's going to work. Let's try it and see. Here is my training data, but that looks to me like they pretty much overlap to where you can't really separate them worth a damn. Just for interest, let's see if it can do any fitting at all. Well, that's interesting. It did fit something through that mesh. So I go back here and look at it. I guess the blue is sort of in the top left and the red is sort of in the lower right. It's a little screwy. So that's what happens with C is 0.001. It puts it all in the blue and has an accuracy of 35%. Well, I guess maybe it's all right. And here's more fitting in the blue. Then it starts finally getting it right here. With the regularization parameter going up to 0.01, now I'm getting something resembling reasonable fit, up to 45%. Then I get 75%. And now I think I've gotten up to where it's pretty much going to stay. That's about as good as it's going to get. Yeah. Well, maybe it's okay. Just looks like my X and Y are sort of inverted or something. So I don't think it'd find the right flag. So I'm going to have to work on that. But anyway, let's see if this data set, the curves one, is going to work. Looks like there's a problem with my project for the middle part. Let's get another new notebook. All right, this is going to give the moons data set. Is it running? Okay. And for the top part curves like a moon, the lower part curves like a moon to get something that's hard to fit linearly. And now we're going to train a linear SVM model with polynomial features added. So it will be able to fit it. We've added polynomial features up to degree 3 here, which is what your book did. And up to 3rd degree is curvy enough to fit this kind of data. So there it goes. And this just shows the diagram of the model, the standard scalar, how it added polynomial features to it. That's creating something called a pipeline. And now to see the decision boundary, we're going to plot it with this data, this code. All right, and see now we get a curvy fit that's good enough. Looks pretty effective. And so then you can do it again, changing it to a 2nd degree to find a flag there. So that one looks like it's going to work. And here's the polynomial kernels version of it, because what we did there was the one where you actually add more features. And this one is going to implement the kernel trick. So if I just continue with the same, because I want to use the same data, I'm not going to erase the book. So I'll run this one. And if the switch is blurry, you need to refresh your browser. Keeps happening to me too. Anyway, by the way, I realize you'll probably be okay doing this project because I didn't create a new notebook halfway through before, so it probably inherited those features from before. That's probably what you do. If you don't make a new notebook and just keep adding more code, it'll probably be fine. I realize that probably kept the X center and Y center what it was before. Anyway, I can fix that in the instructions, so it'll be okay even if you create a new one. But I think it's probably fine. So this is, notice how this only has 3 stages, and this had 4, or depending on how, if you don't count the header, this has 2. Anyway, the point is, this is a simpler series of steps in the pipeline because we're using the kernel trick. We're not adding more features. And so if you go now, if we look at the decision boundary for the one using the kernel trick, we should have essentially the same as the one we got from adding more features. If I can get this thing to work. Why is Control V not working? All right. All right, and there you go. Essentially the same curve with less CPU required to get there. All right. Anyway, that's what I wanted to show you. And I'll stop recording this one.